Good afternoon. It's time to start something new and trust the magic of beginnings. Good afternoon, one and all present here. On behalf of the management, correspondent, principal, and faculty members of ECE, EEE, and VLSI, SA Engineering College, we extend our warm greetings to all. SA Engineering College offers the students an advantageous atmosphere with state of art facilities, distinguished mentors, and a pleasant educational environment. The institution provides the employability and communication skills for the development of students. It provides quality education in an environment of discipline. The focus is on shaping students to become self-disciplined, self-dependent, and self-confident individuals. Introduction to the departments. ECE. The Department of Electronics and Communication Engineering offers BE degree program in ECE and ME degree program in Communication Systems, PhD degree program also in the same. The department is dedicated to academic excellence, innovation, and research. It is backed by highly qualified faculty, many of whom hold doctorates in cutting edge domains such as signal processing, communication systems, VLSI design, RF, and electromagnetics. The curriculum integrates industry driven learning through student led projects, faculty mentoring, industry internships, and active participation in technical clubs. The Department of Electrical and Electronics Engineering offers BE degree in EEE, ME degree in Embedded System Technologies, and PhD degree program. The department is supported by a team of dedicated and highly qualified faculty members with expertise across various domains of EEE. The faculty and students are actively involved in cutting edge research. Our department promotes the professional skills of students through societies like Indian Society of Technical Education and Indian Institute of Electric and Electronics Engineers. Career guidance program and entrepreneurship awareness program are also carried out through the Association of EEE. The Department of Electronics Engineering, VLSI Design and Technology offers a BE degree program in VLSI to prepare professionals for successful careers in the semiconductor industry. The program emphasizes interdisciplinary skills, encourages research and innovation, and provides extensive hands-on experience. It fosters strong industry collaboration, open diverse careers pathways, and aim to maintain global competitiveness in technology and engineering. The department is supported by a team of highly qualified and experienced faculty members with expertise in VLSI design, embedded systems, semiconductor technology, and related domains, ensuring quality education and mentorship. Today's event, Launchpad 2026, Kickstarting BE Beginnings, organized by SA Engineering College on association with ECE, EEE, and VLSI. It gives me great pleasure to welcome all the faculties, participants, and our guest of this event, Mr. Gurumuli Naidu, Assistant Professor, EEE Department, Vignan's Institute of Engineering for Women in Andhra Pradesh. Now, I request our guest to start the session with his introduction and presentation.
Honest madam, am I audible?
Yes, sir, you can start, sir.
Good afternoon, all the dignitaries and other faculty members. My experience. First of all, I would like to say thanks to Dr. Ganesh Madam, my friend. So today our topic is applications of IoT using TinkerCAD. Madam, is it visible? Madam?
Sir?
Madam, my screen is visible?
No, sir, no, sir.
No, madam?
Now visible, sir.
It is okay, madam?
Okay, sir.
We have a topic is applications of IoT using TinkerCAD. So before going to the in-depth regarding the applications of IoT, first we should know what is IoT. In the later, we can discuss about the applications of IoT and how can integrate this IoT design by using the TinkerCAD. One by one, step by step we will see. First of all, we should know what is IoT. Uh, as name itself indicates that the T stands for things. The things which are communicated over a internet, it is called as a Internet of Things. Let it be discussed in depth with a small example. Let us consider an industry where it consisting of number of machines which are located in various locations which are far away from your location. You are the maintenance in charge and you have to monitor a particular motor, healthy conditions. You have to monitor a temperature parameter of a particular machine which is located far away from your location. Then you have to go every time you have to go to the mission and take the readings and come to your location and analyze the readings. Based on the analysis, you have to take proper measures in order to control the parameters. Every time you have to go to the mission, it is a difficult task. In some industries, the machines are fixed with the inbuilt sensors, and again the sensors are fixed with the inbuilt storage devices or storage chips, microchips, right? Where the sensor simply detects the change in parameters of a particular machine, and that the parameters can be stored in a storage chips. In that condition, you have to go to the machine and remove the chip from the device and come to your location and extract the parameters from the chip. They again analyze the parameters and again take the proper measures to control the parameters. It is a delay process. So due to this delay, you may not take the proper measures to control the machine operating conditions. So that's why now the industry shifted to industry 2.0. Again, it is shifted to industry 4.0. In these industries nowadays, all the sensors and the machines and some physical devices like actuators and electrical machines and electrical components and electronic components, all these physical devices can be communicated over the internet. That's why it is called as the Internet of Things. The devices which are capable to communicate over the internet in order to share the information, in order to analyze the information, so that you can easily monitor the parameters of any particular mission from the remote areas. Every time you need not to go to the mission and take the readings, come back to your location and analyze the parameters. You need not to do that process, right? You simply sit in one place and monitor all the parameters of a particular mission, or you can track the healthy conditions of a mission from the remote locations. When all these physical devices are communicated over the internet, that's what is called as the Internet of Things, right? Here, coming to the applications of IoT, the IoT is a very emerging technology where it having a lot of applications, like the applications in domestical applications and agricultural applications, healthcare applications, transportation smart city applications, and smart traffic signal control systems, and industrial applications also, right?
Sir, excuse
Let
me,
I
sir.
give.
Sir, your slides are not moving, sir. Now it is moving.
After introduction, I will change the slides, madam.
Okay, sir.
Right. Let we discuss brief about the each application. Coming to the see, first we have to know the applications of this IoT. Then we have a clarity. What is the importance to learn about this IoT, right? So that's why I'm telling the applications first. So first, coming to the domestic applications, right? I will give you a small example. Let us consider that you have a home. The home is a smart home, right? The smart home means it consisting of the lightning, which is controlled with the IoT things, and smart locking system, and smart alarm system, and smart camera fitting system, right? Let us assume one situation. You are within the house, and one person wants to enter into our home. We have to recognize that person is a authorized person or unauthorized person, right? In that condition, if your home is fitted with a smart door locking system and smart camera fitting system, in that case, when the when a person comes to your door, where the camera simply takes the picture, and the picture is send it to the microcontroller, where the microcontroller consisting of all the predefined data, and the picture is compared with the predefined data. If the picture is matched, it means that the person is a authorized person. Then simply the door is open and the person can enter into your home. If the picture is not matched with the predefined data, that door remains in locked condition. This is the best example for the domestic applications. Not it's a small example. You have a smart lighting system where the lights are on and off based on the claps, based on the hello Siri, and based on the some sounds and buzzers. You can turn off the lights, and you can reduce the illumination of the light. A lot of domestic applications are there. Due to these IoT applications in the domestic applications, you can enhance the safety, security, and also you can reduce the energy consumption, you can reduce the cost consumption also. Coming to the agricultural applications, right? In the agricultural fields, right, you have a crop field. Here, the crop growth is depends upon the water content and temperature, atmospheric temperatures, and the soil moisture content. Right? In this condition, for suppose if you are using the soil moisture sensor, that sensor simply says the moisture values in the soil. If the soil moisture content value is below the threshold value, then simply it will give a signal to the motor, where the motor will submersible water, where the motor will turn on and give a proper water flow. So due to which you can reduce the water wastage and you can increase the crop growth. Coming to the healthcare applications, let us consider a smartwatch. You have a smartwatch, right? Everyone thought that the smartwatch is simply used for quick messaging and quick detection of messaging, whom you are sending or who are sending to you messages. You can observe the calling, those who are calling to you. You can simply observe these things, right? Here, the smartwatch is not only used for those things. The smartwatch is also used for to detect the pulse rate of your body, and to detect the body temperature, and to detect the number of steps while you are walking. Hello? Any doubt? Please mute yourself. So smartwatch is not only used for the messaging and calling, it's also used for hello, someone please mute yourself. Please. The smartwatches are used for not only used for the calling and messages, but also used for monitoring the pulse rates and BP and the body temperature and the number of steps or number of steps on while you are walking. So that you can easily, in prayer, you can allot the doctor duty, not to protect yourself. And coming to the transportation and smart cities, where the smart cities, let us consider a smoke detection sensor. If you're using your surroundings, the smoke detection sensor will simply detect the smoke contamination so that you can control the air pollution. And at the same time, if you're using the smart traffic signal control system, due to which you can optimize the vehicle parking and you can control the traffic flow, control and you can control the traffic at the signal tasty areas, traffic tasty areas. Coming to the industries, we have a number of industries in which they are using number of sensors not to monitor or not to track the healthy condition of emission. So due to which you can easily reduce the costly downtime of emission. These are the various not these applications are not limited. Number of applications are there based on the IoT, right? This you can observe the what are the components which are involved in the IoT, right? Basically, the IoT involves the sensors, where the sensor simply used to detect the physical conditions or physical parameters of emission or objects or devices, where the physical parameters can be converted into digital data. Like the sensors, like temperature sensors, light dependent sensors, soil moisture sensors, gas sensors, and also the IoT consisting of actuators. The actuators simply works based on the commands and they can do the physical actions. Just example for the actuators are LEDs, motors, relays, and servo motors and sensors. These IoT components or devices are connected via maybe Wi-Fi and maybe through Bluetooth. They can connect. They can connect in GPA and LoRa by using GSM or by using Ethernet or by using internet. Right? Here we have two IoT components. Such smart objects capable of sensing and communicating and enhancing information through the internet. For example, let us consider a smart thermostat. What is the main purpose of the thermostat? It is used to control the room temperature. Likewise, the smart lighting, where smart lighting means already we have discussed. The smart lighting means the lights are on and turn off based on based on the remote signals. It can increase decrease the brightness. Coming to the smart door locking system, where enables the secure remote access. Coming to soil moisture sensors, measure soil moisture for irrigation, and weather station that monitors environmental conditions. These are the different components that we are using in the designing of IoT. Coming to this is the best image which shows how the IoT devices are interconnected. Right, we have already discussed the devices in the IoT. Right. These are the input devices and these are the output devices, and these input and output devices are interconnected to the microcontroller Arduino via internet or via Wi-Fi, or we have a number of interconnection ways, right? You can use a Zigbee, they can use a Ethernet, right? These are the different components in the IoT. Coming to what is IoT, we have already discussed that IoT is nothing but simply stands for Internet of Things, where the physical devices are every day. These objects like sensors and applications like machines and actuators and the electrical components, electronic components are interconnected via internet and for the collection of data, for analyzing the data, and to act on it automatically without human intervention, right? This is about the IoT. The IoT consisting of a simple loop. This loop can be explained in this example, right? So the IoT IoT-based smart irrigation system with the data flow diagram, where it consisting of different input components and different output components, which are connected to the microcontroller with a Wi-Fi and a cloud platform. Right, we have a plant where it grows over a soil, or it needs a proper moisture level. The moisture content in the soil can be sensed or measured by detected by the soil moisture sensor, where the detected parameters can be transmitted to the Arduino, where Arduino consisting of microcontroller, where it reads the data and analyze the data, and the analyzed parameters can be transmitted to the mobile app, where we can observe the soil moisture with 28% and status is dry, and the data is transmitted from the microcontroller to the mobile app via Wi-Fi and by using the cloud platforms, right? After seeing this status, like the moisture content is very dry, then you can here the user checks moisture level. So based on the comments what you are given through the mobile app, the signals are again sent it to the actuators like relays, right? Actuators, the signals are sent from the mobile to the microcontroller and microcontroller to the relays. The relays simply turn on the water pump. So based on the water flow to the soil, again the moisture level may increase. So this is a simple IoT flow, where it consists of a sensing devices and a microcontroller and a networking system. And these sensing devices are connected to the microcontroller. Microcontroller connected via internet with the mobile app, and some output actuators and output components also. This is a simple flow diagram of a IoT. Here you can observe that in the IoT loop, you have a sensor. It simply sense the or detects the physical parameters of an object. The sensors may be temperature sensors or motion sensors or light sensors, where these sensors are connecting with the microcontroller through the network, where the microcontroller can simply process or analyze the data which is received from the sensor, right? And generate a proper comments, and that comments are sent it to the actuator, where the actuator can actuate the output components. Based on the proper measures, we can control the output components also, right? The microcontroller itself cannot do all the things. It needs some assembly. That assembly is called as a Arduino assembly, right? So here you have a large chip. This chip is called as a microcontroller. This microcontroller integrated with all the other components like it consisting of diodes, and it consisting of transistors, oscillators, and resistors, LEDs, all these components, and voltage regulators, 3.3 voltage regulator, 5 volts regulator, so push buttons. All these components are required to improve the performance of microcontroller, right? So here the microcontroller needs some commands or some programmed data that can be dumped into the microcontroller through the USB plug. We'll discuss later about this Arduino. So basically, the microcontroller itself cannot do all the performance things. It needs some assembly. That assembly is called as a Arduino Uno, where the Arduino Uno consisting of microcontroller. It needs the command signals which are written in the C++ language, and it's a very simple language. Right. So we can connect these. We can connect these input and output devices with the Arduino in a real time, as well as in a online simulator also. That online simulator is called as a TinkerCAD, right? If we'll discuss about the TinkerCAD with a small example. Let us consider you are the vendor and I am the customer. When the customer come to you and ask to design one prototype, one electrical vehicle, prototype electrical vehicle, they have asked you to design. That condition, so you have some knowledge or the design of electrical vehicle, simply go to the shop and purchase the assembly things and come to your location and can assemble all the things which to design a prototype electrical vehicle, right? Do you think that the prototype designed electrical vehicle gives a exact output what the customer needs? We cannot sure. So that in that condition, the skilled persons what they are doing, right, when customer come to them and ask to design a particular electrical vehicle based on their requirements, then the skilled persons immediately use a online simulators or use a the simulating apps like MATLAB and like TinkerCAD, where the TinkerCAD is used to design electrical circuits and electronic circuits. You can easily build the circuits and you can simulate the circuits, you can run the circuits and get the output, right? There you can easily match the output with the customer requirements. If the output from the TinkerCAD design, what you have designed, if the output is matched with the customer requirements, then you can go to the actual design, or you can go to the prototype, or you can go to the actual design. Right? So without the simulation results, we cannot go to the actual design, or you can go to the prototype. Why? Because if you are go to the prototype design, if you are go to the real-time design, it is a very cost effective. Why? Because the output of that designed object is not matched with the customer requirements. Again, it should be disable all the things. Mean uh, reassemble again, and every time we have to check the output with the customer requirements. It's a very costly process, and it's a very time consuming process. That's why we have to go for the simulation tools. Where in the simulation tools we can easily simulate. You can easily simulate the uh, what the customer needs. You can easily simulate the circuits and run the circuits and get the output results. We can compare the results with the customer requirements. Right? The main advantage in the simulation IoT projects that zero risk means low danger of short circuits, burning components, and basic budget while learning, and no hardware needed. Simply the TinkerCAD can see that TinkerCAD is nothing but it is the online free platform tool where you can design the electronic circuits and the electrical circuits, right? And you can run the simulation and you can get the output, right? That's why it doesn't need any hardware components like the sensor, ports, and tools. Itself, it consisting of all the tools, right? Instant debugging, right? You can modify the connections and you can again resimulate the connections and you can get the modified output. That is the main advantage of this online simulator called the TinkerCAD. Easy sharing, the projects are saved online and can be shared, copied, and created with the link, right? I will show you a small demonstration regarding how the TinkerCAD works and how the components can be integrated in the simulation tool. So simply go to the simply go to the Google and type TinkerCAD. A slide is visible. Simply go to Google and type the TinkerCAD online simulator. Then you have one dashboard. Then you have a different links where you can see the TinkerCAD logo with a 9 color symbol. TinkerCAD, TinkerCAD, 9 color symbol. If you click the TinkerCAD symbol, then you can get a online dashboard where you can integrate your Google account with the TinkerCAD. Why? Because this TinkerCAD tool is a cloud-based tool. That's why you have to connect your Google account with the TinkerCAD. So when you're when you're linking your Google account, when you're clicking your Google account, then you have it. You can get this dashboard where you have a number of components, and all these components can be simply dragged into the editor board. You can easily drag these components into the editor board, and you can easily connect this component with the Arduino. And you can code the Arduino where it consisting of microcontroller, right? Microcontroller needs some coding. You can easily code the Arduino by using this online editor. Later, you can start simulation. We simply start simulation. It will give the we start simulation and simply give an output, right? My logic is simply show my name is hello Mulinaidu. My simply show the name is in a LCD display. That's why I'm using the Arduino and LCD display. Code it and start simulation. It shows the output, right? Likewise, you can connect a different components. Another example, this is ultrasonic distance sensor where you can simply connect all these components. With the ultrasonic sensor, you can easily measure the distance. This is the application of self-driving cars, right? Where you can when the self-driving car is moving, if any obstruction is there, and they can measure the distance of the obstruction and simply take a diversion. In that case, you can use this application. In the car reverse parking application also you can use it. Right? So if you start simulation, after connection of all these components, you start simulation, you can see the distance of the object. You can see the distance of object. So after start simulation, the distance of the object, that is the object is moving, the distance of the object can be measured by this. The ultrasonic distance sensor simply measures the distance of the object and send it to the Arduino UNO. And when the Arduino UNO simply sends the command signal to display the distance of the object over a LCD display. You can monitor the distance of the object in that display, right? So this is a small demonstration regarding how the TinkerCAD works and how the TinkerCAD can happen, right? If you want to do the real-time prototype with the Arduino, you need Arduino IDE environment. Simply Google it Arduino IDE environment and download the Arduino IDE environment file based on your system requirements. It may be Windows or maybe a Linux based or maybe different Mac based, right? Depends upon the system requirements. You can download the Arduino IDE. So there, the Arduino IDE, it is a online tool, integrated development environment where you can develop a program for the Arduino, and later we can compile the program, and the program can be, if the compilation, if it consisting of any errors, we can modify the errors within the IDE also. Later you can dump that entire program into this Arduino, right? This is the Arduino IDE environment where you can develop the program, and this program can be easily compiled here by clicking the verify, and later this program can be dumped into the Arduino kit by using this upload button, right? When you are clicking the upload button, the program simply dumped into this hardware component Arduino, right? the Arduino hardware component, right? After dumping, it will give the proper results based on the command signals and based on the coding. It will give a output signals, right? This is about the simple demonstration regarding the TinkerCAD and Arduino IDE. So these are the different applications we have already discussed. Smart home automation, where it consisting of four main components: Arduino Uno, PIR motion sensor, relay module, LED lamp, where the PIR motion sensor detects the movement in the room, and the Arduino leads a high signal. Arduino simply reads a high signal in the sensor pin and code triggers the relay to and the lamp turn off automatically. Based on the time delay, it will turn and turn off the lamp based on the input signal, like velocity, turn on the lights on and turn off the lights based on the signal also it will turn and turn off the LEDs. And this is the simple IoT diagram for the smart home automation. You have a number of home automation electrical appliances, where the appliances are interconnected with the Arduino Uno board. Where this Arduino Uno board consisting of microcontroller. This microcontroller simply control these lights and fans based on the input signals, and this based on input signal simply control these turn off the lights by using the flash and also that's main advantage of smart automation. Coming to the next application, smart agriculture system, where it mainly consists of Arduino Uno, soil moisture sensor, and water pump relay, and LCD display. Basically, the soil moisture sensor simply detects the moisture content in the soil, and it will give it to the Arduino Uno, where Arduino Uno simply analyze the signals which are received from the soil moisture sensor and give a proper command signal to the water pump or relay, where the relay actuates the water pump and it will turn on. Right? And the soil moisture sensor also gives the parameters to display the values in the LCD display also. Right? This is a simple connection of a water moisture sensor with Arduino IDE. This is one IoT design, where it is consisting of motor, display, and the moisture sensor. Right. Whenever this moisture sensor digs into the soil, this moisture sensor simply senses the moisture levels, where the moisture the signals are the detected parameters can be transmitted to the microcontroller, which is registered in the Arduino Uno, and where it processes the signals and give a proper commands to the motor to a relay. Where the relay simply turn on the motor. Again, the moisture level may changes, depends upon the water flow. This is the simple operation of the smart agriculture. The next application is a health monitoring system, where the health monitoring system it is considered a small example where the temperature sensor, in order to measure the body temperature, it needs a temperature sensor. The temperature sensor reads the body temperature and give it to the Arduino, where it Arduino processes the temperature value. If the temperature value is lower than the predefined value, it is okay. If higher than the predefined value, then it gives a buzzer. So in such a way that you can alert the doctor in 3 years to protect ourselves, right? And the temperature sensor sensor readings also can be displayed or LCD display or organic LED display. This is the simple connection of a temperature sensor with LCD, the Arduino Uno. It's a heartbeat sensing component, where it can easily sense the heartbeat, and that can get transmitted to the Arduino. And Arduino can display the heartbeat also about the healthcare applications. So coming to the smart street lighting system, where it requires Arduino Uno LDR relay and a smart street lamp, where the LDR light dependent resistors simply depends upon the photon energy follow the LDR, the resistance may changes. LDR resistance may changes based on the resistance change. The current passing through the street light also changes. And based on the current passing through the street light, it may glow very brightness or glow dim, and depends upon the light photon energy all over the light dependent sensors. Right. This is the application of smart street lighting. Coming is a simple connection of a smart street lighting, which one LED is connected to the LDR to the Arduino, where the LDR senses the photon energy follow this LDR based on the photon energy. The resistance may changes based on the resistance. The current passing through the LED also changes, where the LED is lower and goes up depends upon the example. And coming to the next example is the free gas, higher-end gas safety alert, right? Where it uses a gas or a flame sensor. It simply sends the gas accumulated your surroundings. If the value is more than the predefined air quality value, then Arduino simply gives some warning through the LED or through the buzzer. These are the different small applications by using the IoT, right? And what are the advantages of, or what are the limitations, and what are the benefits of this IoT applications? Designing of Arduino circuits, designing of electronic circuits by using the TinkerCAD, right? The benefits of a simulation where it is free and accessible from any browser, right? You can design your system, you can design your college system, you can design the circuits anywhere from any system, right? Through any browser. And another advantage is safe experimentation with no equipment risk, right? It doesn't need any hardware components. This online TinkerCAD simulator consisting of all the component libraries itself, and you simply drag the components into the environment dashboard, where and these components can be easily connected through a bytes, and you can run the simulation, right? Instant feedback speeds learning, right? It will give a proper output instantly, so that you can instantly can learn the things, right? Great for classrooms without a hardware labs, right? We cannot do it in hardware. We can do it in a you can do it in a laboratory also. You can do it in a classrooms also by using the laptops, by using the systems, right? Designs can be exported to real Arduino boards, right? So whatever the design you have done in the TinkerCAD software, the same design can be implemented in a real time by using Arduino boards, right? These are the advantages. But the main limitations of this TinkerCAD online simulator, the more real world noise, and sensor data is idleized. We cannot hear the real world things, right? But this is one product where cannot simulate mechanical wear or timing gaps. Mechanical wear and teeth they cannot design in a TinkerCAD simulation. The limited components and sensor libraries. It consisting of one a digital library, where the digital library consisting of all these input and output components, but those components are limited ones, right? So the real-time components, whatever the real-time components exist in the real time, all those components are not included in the libraries. That is the main drawback. So that we can design a circuit limitedly, limited small circuits we can design, right? So more to wireless networking or behavior. And when you are designing the when you're designing the simulation in a online, so you cannot communicate this TinkerCAD by using the Wi-Fi, by using the cloud. That is the main drawback. But whenever you are designing the same components in a real time, so you can communicate all the components. You can make the circuit to communicate all the components via internet. So that is the main drawback. So we cannot communicate all the components in a TinkerCAD via internet. That is the main drawback. The final testing on a real hardware is still essential. Right? Uh, it is not a big drawback. Final testing means that even though you have designed one circuit in a TinkerCAD simulation, it will give a output, and that output is matched with the requirements. Even though whenever designing the same circuit in the hardware components, you may not get a proper output. So that is the main drawback with this. Right? So that finally we have a conclusion that by using the TinkerCAD online simulator, we can easily design the prototypes in online, and we can easily run the simulation, or we can easily run the design, and we can get the output, and we can verify the output with the requirements. The output is not matched with the requirements, and we can reconnect or rearrange the circuits, again run the simulation. We can do it in number of times. That is the main advantage. If you do the same thing in a real world, you have designed a one prototype in a real world with all the soldering component, with all the components by soldering. If the output of the designed object is not matched with the customer requirements, or not matched with the output requirements, we have to remodel the circuit, reconnect the circuit. It is not possible. Every time we have to disconnect the circuit, disassemble the circuit, and reconnect the circuit is possible. Then the components may damage, may get damaged. That is the main drawback with the real world designing. That's why you have to first go with the online simulator and do the design and get the output. Finally, you can, if the output is exactly matched with your requirements, you can proceed with the real world design, right? We can design the electronic circuits, electrical circuits, the healthcare related, home related, traffic sensing related, and transportation related, agricultural related. You can design anything, but with a limited components, right? So, students have any doubts? Please ask me. Please, you can ask me if you have any doubts regarding the TinkerCAD online simulator, and how to do the connections, how to design the circuits in a TinkerCAD. See, it is not only for similar topic. I have a vast number of applications. It is best useful tool for you to do the CSP related projects, community service based projects, to do the internship based projects, and to do the mini projects, and to do the major project also. That's why please try to learn, to know these things, right? The, is the easiest thing. TinkerCAD online simulator is the very easiest thing. If you have any doubts regarding these things, you can directly contact me. My number is with Dr. Bhuvneshwar Madam. You can ask Madam, and you can directly contact with me. I'll explain. Have any doubts regarding this, you can ask me. Thank you. Thank you.